All right, so the other one we could do is the decomposition of hydrogen peroxide. That's H2O2. And just on its own, like if you let your hydrogen peroxide sit in the cabinet for too long, you'll feel it kind of swell up like this. That's because inside there, the hydrogen peroxide is decomposing. So what happens is that over time, it just falls apart into H2O and O2. Now, one thing we could have worked on yesterday is right now when we look at this balanced, I've got an H over here and an H over here and an O over here and an O, and then I got an H and an H and then one O and then one, two more. So I got 3 O's on this side, 2 on this side, 2 H's on this side, 2 H's on this side. So the hydrogens are balanced. I need to find a way to balance the oxygens. So oxygen on this side is even. I'm gonna have to make the oxygen on this side even. So one way I can do that is say I need 2. I'm gonna get 2 here. But then remember that it's distributive, so it goes into the whole water molecule. So it also does that to the hydrogen. Okay, so now I've got 4 oxygens over here. I got 4 hydrogens over here. I need 4 hydrogens and 4 oxygens. I got 2 of each right now, so real simple. Distributes into the whole thing. And now I've got 4 and 4 and 4 and 4. This is all balanced. So it's going to take 2 parts hydrogen peroxide. It's going to make 1 part oxygen and 2 parts water. So let's look at that one in a reaction real quick. You can pause it now. Okay, so we'll put the hydrogen peroxide in first. And like I said, this might be a little bit older, so we'll see how well it works. As it ages, another thing that affects the rate of reaction, another thing that's in this section that we're going over, is as it ages, right now this is where when you buy it, it's at 3%, and as it ages and falls apart, that percentage goes down, and so the concentration goes down. So if we were at school, we could order stuff like 30%, and this reaction would really go. The other thing I want to add is a little bit of Dawn dish soap, and that's going to just work to trap that oxygen that we're creating right there. And then to make this one happen quicker, another thing you see for changing a rate of reaction is having a catalyst. And so there are a bunch of different types of catalysts that we can use. We're going to use yeast in this one. And then as you watch, as it works, as it goes, bubbles will form, and we're trapping those bubbles in the dish soap. Like I said, this one is probably older, the concentration is way down, so the reaction is much slower. Think about, 30% would be one that you'd see in a video where it all shoots out at once. This is going to go really slow. Yeah. So the more yeast that's in there, the more surface area that the yeast is working on. You want to go get a plate real quick?
Sure.
And that surface area is going to make the reaction go faster. So you'll see this thing get to the top here really quick. That was close. And the other thing you notice is that this will get a little bit warmer, especially where the reaction is happening. It might go up for this low concentration, it might go up a couple degrees. For that really high concentration one, the water will boil right away.